So on to the second problem of the run-up contest of the 2006 MIT Integration B finals, which is the definite integral of 1 over x plus the square root of 1 plus x squared. Another very interesting problem. Let's see how we may be able to solve. What one would want to do is multiply the integrand, the numerator of the integrand, with x minus square root of 1 plus x squared. So that looking at this part here, we have a difference of two squares coming up, right? So the denominator now becomes x squared minus the square of the square root of 1 plus x squared, which becomes 1 plus x squared. And we quickly see that these x squareds cancel, and the numerator remains x minus square root of 1 plus x squared. And since we're left with negative 1 in the denominator, we can now pull the negative sign out, and we have the integral of x minus the square root of 1 plus x squared. One thing obviously we could do is we could separate these integrals so that we can integrate x here, and that becomes negative of x squared over 2. And then the second integral now becomes the integral of the square root of 1 plus x squared. Now, let's and now separate and maybe color code that second part of our solution. So the integral of the square root of 1 plus x squared, we could color code it green, and that means that we can now go ahead and try and see, maybe we could substitute tan u for x. So dx du becomes secant squared u, and that means we can substitute dx for dx with sec squared u du. And therefore the integral of the square root of 1 plus x squared is the integral of the square root of 1 plus tangent squared of u times secant squared u. So 1 plus tan squared u is the same as sec squared u square root. That means that becomes sec u times obviously the sec squared u. Now going forward, what that means is we can express sec squared u as a derivative of tangent of u, and that means that we can now exploit integration by parts. And what does integration by parts tells us? It tells us that if you're integrating a product of two functions, one v and one the derivative of capital U, the solution to that will be the product of uv minus the product of function u and the derivative of v. So we see that the derivative of u can be equated as the derivative of tangent u here, and v can be equated to sec u. So what is our uv? Our uv becomes sec u tan u minus sec u here happens to be tan u. The derivative of sec u is sec u tan u. So we have, sorry, this is u, sec u tan squared u. And sec squared u is the same as tan squared u plus 1, therefore tan squared u is equals to sec squared u minus 1. So we can substitute this in place of u here. And that means that now we have sec u tan u minus the integral of sec u times sec squared u minus 1. This becomes sec u tan u minus the integral of sec cube u, and this happens to be the same as this integral here. So what we can do is we can call this integral I. And since we have I on the left hand side, so we have I equals to sec q tan u minus I plus the integral of sec q. So we can pull this I onto the left hand side so that we have two i's being equal to sec q tan u minus, plus the integral of sec q. So I won't go so much into the details, but the integral of sec x is equal to the natural logarithm of sec x plus tangent of x. That's the integration constant, c, obviously. So we're going to use this relationship. You can go and look for it, or we can, if you need us to show and prove it, please leave a comment in the comment section. We will be able to show you how to show that. But I here is the same as half sec q tan u plus half the integral of sec q, but we already know what sec q is now from this expression here. So we have I being equal to half sec q tan u plus half the natural logarithm of sec q plus tan u. And so since x is equals to tan u, and therefore u being equal to the arctangent of x, that means that I is equal to a half the arctangent of x times tangent of arctangent of x plus half the natural logarithm of the second of the arctangent of x plus tangent of the arctangent of x. And in fact, we shouldn't be calling this I. This is our original integral, which is the integral of square root of 1 plus x squared is equals to half second of arctangent of x, the same as the square root of the tangent squared of the arctangent of x, which is x squared plus 1 times x plus half natural logarithm of the second part of the tangent is square root of x squared plus 1 plus x. So meaning that our final answer, which entails the combination of both the negative x squared over 2 and the green integral, is negative x squared over 2 plus this part here, which is half x times the square root of x squared plus 1 plus half the natural logarithm of x squared plus 1 plus x. And that is the answer that was expected. So that was fun, and